Hi, this is Algebra 1, Lesson 4-3, Solving Systems of Equations by Elimination. So far in Lesson 1, we learned how to solve equations in graphing. And in Lesson 2, we learned how to solve equations by substitution. In Lesson 3, we're going to solve systems of equations by elimination. Let's look at critique and explain. Sadie and Micah use different methods to solve the system of equations. Sadie's work is shown below in green. Micah's work is shown below in red. And they both get the same solution. In what ways are Sadie's and Micah's approaches similar? In what ways are they different? Do you see differences between the two works? Okay, we start with these two equations. We have y is equal to 2x plus 3. So Sadie substituted 2x plus 3 instead of y, all right? And then she solved for x, and then she solved for y. Micah is solving, however, x first, right? He's saying that the two equations are both going to be equal to y when he changes the second equation to this one. And then since y's are equal to each other, why don't you just let them equal to each other? And then you solve for x, and then you solve for y. Okay, the order may be different, and also it is still substitution, but the order of solving the variables were different. Okay, so you can say that they both solved it algebraically. Okay. Sadie uses substitution, and Micah lets two equations equal to each other. Okay. Are both Sadie's and Micah's approaches valid solution methods? Are they valid? Well, they got the same solution, so why aren't they? Right? So yes, explain. They clearly show the steps of how to solve the system, and they have the correct solution. Steps are clear. Same solutions. Okay. Which method of solving systems of equations do you prefer when solving? Sadie's method or Micah's method? Which one do you prefer? Which one do you think is less work for you? Which one is easier for you? Okay. Since your y is already solved, it's less steps and less work to use Sadie's work because you have to convert, first of all, the second equation to the y equals sign, right? So you can say Sadie's because it's less steps. You can choose Micah's because of whatever reason you have. Because you may want to deal with y equals. You're more comfortable with dealing with equations that are in slope-intercept form. All right, so in this lesson, we're going to think about why does the elimination method work when solving a system of equations. Okay, let's look at example 1. Solving a system of equations by adding. What's the solution to this system of equations? We're gonna use a different method called elimination. When we have the same like terms here, the variables that have x and y, and the constants, we're gonna match the like terms, and these two equations are different, but we're gonna add the whole equation. So we're gonna add the x and the y and the numbers. And then we have this. Okay. Why do we do this? Because if we do that, we get rid of y's. Okay. If you add the whole thing, if you add the whole equation, then it is solving for an intersecting point. Okay. This method works because of the addition property of equality. Because since 2xy, 2x minus y and 2 are equal, this is y. Since 2xy and 2 are equal by second equation, you can add 2x minus y to the left side and 2 to the right side, right? So then you're adding the same thing. That is why we're adding the whole equation. Does that make sense? So in order to change the equation, you have to add the same thing or subtract the same thing. But we are doing that. It looks different, but they're actually the same thing. We're adding the same thing because 2 is equal to 2x plus y. Okay, so we're not changing the equation. Look carefully at the last two steps. They're the same as adding like terms in the original system of equations. So that was what we were originally doing. Okay. So 3x is equal to 9, and so x is equal to 3. Substitute 3 into x in order in either of the two equations, and then you'll get y, the value of y. So yes, you will use substitution at the end, but when you start, it's going to be a little bit different than the substitution method. You start with elimination, then once you get the variable, you do have to substitute. Okay, try number 1A, come back when you are ready. Try by yourself. Okay, solve the system of equations by elimination. It is easier to solve it by elimination because we have 4y and negative 4. If you add them, they become 0. So you can eliminate it. That is why it's called elimination. Okay, if you add them, it's 0, but you can't just add a part of an equation. You have to add the whole thing so that you don't change the equation. Okay, you're following the rules of solving an equation. So 2x plus negative x is going to be 2x minus 1x. So that's x. And x is equal to 2 plus 3, which is 5. Now we got x is equal to 5. Wasn't that easy? You plug it into any one of these equations to figure out y. I'm going to use the second one. Negative x plus 4y is equal to 3. So 4y is equal to 3 plus 5, or 8. And so y is equal to 8 divided by 4, which is 2. Okay, so your answer is 5, 2. That is your point, 5, 2. Part B, this is also easier to solve in elimination method because you have 2x and negative 2x on the other, on each of the equations. So you can match them and eliminate the variable x. Okay, you add them, add the whole equation. And then you add the y terms. You have 5y is equal to 1 minus 6 is negative 5. So y is equal to negative 1, and plug that in, substitute it into your any of your equation. I'm going to choose the first one now. 2x plus 3 times negative 1 is equal to 1. So 2x minus 3 is equal to 1. So 2x is equal to 1 plus 3, which is 4. So x is equal to 4 divided by 2, which is 2. So your solution is 2, negative 1. Okay, that was the elimination method. Let's look at example 2. Understand equivalent systems of equations. What is the solution to the system of equations here? Okay, before adding equations, multiply each side of one of the equations by a constant, so that makes either the x or y terms opposite. So if you don't see a term that's matched already, you might have to match it. If you're using elimination, you have to match it. Okay, so we're gonna multiply by -2 for the first equation, so that you have -2x. You're matching the x terms because it's easier to match the x terms than the y terms, because LCM of 3 and 2 is 6, right? LCM of 1 and 2 is 2, so it's easier to just multiply one equation rather than multiplying both of them, right? Less chance for mistakes. So then you match them. You have -2x and 2x, so you've matched one term, and you're gonna get rid of them. You add the whole equation, eliminate x, you get 4, -4, y is equal to -8, so y is equal to 2. And you're going to substitute 2 into either one of these equations and solve for x, which is 1. So your solution to the system is 1, 2. Okay, so elimination method does not always have to be when they have a matching term. You can match them in order to use the elimination method. Okay. And sometimes even including the matching steps is less than substitution or graphing, or yeah. So let's try number 2, A and B. Come back when you're ready. Okay, so this system of equation by matching them and using elimination method. So it's easier to match the first one to the second one because you have x and 2x. It's easier to just multiply the first one by 2. Okay, so then you have 2x plus 4y is equal to 8. And they're both positive. So why don't we multiply it by -2? And that becomes negative, and that's actually negative. Okay, and that's negative as well. So you have 2x minus 5y is equal to -1. You add them, x is eliminated. You have -9y is equal to -9. Y is equal to +1. You are not done. X plus 2 times 1 is equal to 4. I'm substituting 1 into the first equation. And you have x is equal to 4 minus 2 is 2. Your solution, final solution is 2, 1. Okay, part B. Is it easier to match the x terms or the y terms? It doesn't matter. Just choose any terms. Okay, it might be easier to multiply 2 for the first one, +2, or you can multiply -2 on the second one. It really doesn't matter. But if you just want to multiply +2, then pick the first one. You can multiply the whole equation by +2, and you get 4x plus 2y is equal to 4. And x minus 2y is equal to -5. So you add the entire equations and you eliminate y. You get 5x is equal to -1. X is -1/5. Okay, it's a fraction and that's fine. Substitute this into your second equation. You get -1/5 minus 2y is equal to -5. -2y is equal to -5 plus 1/5. Okay, -2y is equal to, so that's -25/5 plus 1/5. So that's really -2y is equal to -24/5. Okay, it's fine if it's not a whole number solution. It doesn't mean you're wrong. Okay, -24/5 divided by -2 is your y. And so you're going to divide 24 by 2, and the negatives cancel out. So y is equal to 2, wait, that's 12. 12 over 5, okay? So finally, your solution is negative 1 over 5 from your x, and then 12 over 5 from your y value. Okay, together, this is your solution. This point is your solution. Okay, good. That was elimination. Example 3, we're going to apply the elimination method. The florist is making regular bouquets and mini bouquets. The florist has 118 roses and 226 peonies to use in the bouquets. How many of each type of bouquet can the florist make? So each regular bouquet has 5 roses and 11 peonies. Each mini bouquet has 3 roses and 5 peonies. So the equation for roses would be 5x plus 3y equals 118 when x is the number of regular bouquets and y is the number of mini bouquets. Okay, and peonies would be 11x plus 5y equals 226. Now we have 2 equations, and we're gonna solve this using elimination method. Okay, we're gonna match the term y, the y terms, into their LCM 15. And then one has to be positive, one has to be negative, so that we can eliminate them when we add them. So we're gonna have x is equal to 11. Substitute 11 into any of the equations. You solve for y, 21. The solution is 1121. What does that mean? X represents regular bouquets, Y represents mini bouquets. So the florist has enough roses and peonies to make 11 regular and 21 mini bouquets. Okay, so after you solve it for word problems, you need to know what it means. Let's look at try number 3. Before the florist has a chance to finish the bouquets, a large order is placed. After the order, only 85 roses and 163 peonies remain. Ooh, how many regular bouquets and mini bouquets can the florist make now? Okay, so we have the same equation, except it's gonna equal to 85 roses and 163 roses total, right? Peonies total. So we're going to copy down the roses equation and peonies equation. 5 plus 3. 5x plus 3y is equal to 85 roses. And then how many were those? 11x plus 5y is equal to 11x plus 5y is equal to 163 peonies. Okay, and then we're gonna solve for x's and y's. Let's also match the y terms again. So we're gonna multiply the first equation by, let's do -5 and +3 over here. Okay, so -5, -25x, -15y, and then negative -185. Okay, and then we have times 3. We have 33x plus 15y is equal to 489. Yes. Okay, and then we add them. Y's are eliminated. X is going to be 33 minus 25, which is 8x, is equal to 4, 0, and then 3. 304. Wait, is that right? Yeah. Okay. So then x should be equal to 8. Wait, no. x should be equal to 15. And then if you plug it in, 5 times 15 plus 3y is equal to 85. That's going to be 75 plus 3y is equal to 85. And then you have 3y is equal to 10. Wait, is that true? Yes. And y is equal to 10 over 3. Let's look at this again. Okay, I was having a brain fart. For some reason, I did not multiply that correctly. 85 times -5 should be -425, right? Yeah. And let's check 163. 163 times 3 should be 489. Okay, that's good. Okay, good. It was just 85 times 5. So, yeah, so sorry. 489 minus 425 should be 64. So that's actually not 15. It should be 8, right? Yes. So we have 8 regular bouquets. Plug that in. 5 times 8 plus 3y is equal to 85. So that's 40 plus 3y is equal to 85. And that's 3y is equal to 45. Y is equal to 15. There you go. And now we can say our solution point is 8, 15. But what does that mean? How many regular bouquets? How many mini bouquets? We have 8 regular bouquets and 15 mini bouquets. Okay, this is the final answer. Okay, good. Let's look at example 4. Choose a method of solving. Now you have learned by different methods using graphing, solving by substitution, and solving by elimination. Now you might have your favorite method by now. You can choose a method of solving using your favorite method or the easier method. Yes, there are cases where it is obviously easy to choose one method over all the other. Okay, graphing is not as exact. Substitution might not be convenient when you can just eliminate easily, right? So you have to look at the situation. Look at part A. Which one would be the easier way? Y is already solved. That means you can substitute this easily into your second equation. So in this case, you're going to use substitution. Okay, solution is -9, 4. In this case, look at your coefficient for the second term, right? -2y and -4y, they're very close. So if you just multiply the first equation by -2, then it's easy to match your y term instead of solving both of them by y, right? Instead of solving for one variable and then using substitution, it's less work to match one equation and then use elimination method. And then you're going to solve for x and y, and you have a solution -3, -8. Okay, so let's look at try for A and B. What's the solution for each system of equations? Explain your choice of solution method. Okay, so for part A, which method do you want to use? Is it easier to solve for one variable and then substitute? Or is it easier to match one equation to use elimination? For part A, it's easier to match the second equation with the first one because you just need to multiply, right? So elimination, we're going to use elimination because it's easier to multiply by -2 to match the x terms than solving both equations for a variable. Okay, so let's solve it. We have the first equation, 6x plus 12y equals -6. And we're going to multiply the second equation by -2, and we get -6x positive 4y is equal to positive 54. Okay, and then we eliminate x. 12 plus 4 is 16y. 54 minus 6 is 48. And so y is equal to 3. And then you substitute it into your second equation, and you get 3x minus 6 is equal to -27. So 3x is equal to -27 plus 6 is -21. X is equal to -7. Your solution is -7, 3. Okay. Which method is easier for part B? For this one, x is already solved for, right? So it's easier to substitute. So substitution, we're going to use substitution because x is already solved for. It's easier to substitute x equals 6 minus y to the first equation. Okay, so let's do that. 3 times 6 minus y minus 2y is equal to 38. And you have 18 minus 3y minus 2y is equal to 38. 18 minus 5y is equal to 38. And so -5y is equal to 38 minus 18, which is just 20. And then y is equal to -4. Okay, and then you're gonna plug it back into your second equation. X is equal to 6 minus y, which is -4. So x is equal to 6 plus 4, which is 10. Okay, so your solution, final solution is 10, -4. There you go. Okay, so there are times where elimination method is easier. There are times where a substitution method is easier. You need to look for the hints, okay, how the equations look like. All right, so in this lesson, we learned about elimination versus substitution. What's the easier way for different types of situations? So when one equation is already solved for one variable, or if it's easy to solve for one variable, you can use substitution. When you can multiply one or both equation by a constant to get like coefficients that are opposite, then you need to use elimination. Okay, so we learned how to use elimination, and we learned how to see which one's easier to use. That was lesson 4-3, solving systems of equations by elimination. We'll continue with lesson 4 in the next video. Thanks, guys. Bye.